Now this last one's a little bit different. And then if I do the prime factorization of 10, I just get a 2 times 5. 11 is just 11 because it's a prime number. And 14 is 2 times 7. It's 2 times 7. Um, so if you're just looking here, I can't think of a larger number than 1 that's the greatest common factor of a 10, 11, and a 14. And sure enough, if I do the prime factorization, it's not going to work, right? Because the 11 only has 11 as the prime factor, right? And 11 is not in the first one. 11 is not in the third one. Therefore, there is no prime factor other than 1. I do want to emphasize that technically, if you don't see a greatest common factor, it's understood to be a 1, right? And you can actually see that right here. If I divide all these, the largest number that I can divide all of them by is a 1, because you can divide anything by 1, generally speaking. So 10 divided by 1 is 10, 11 divided by 1 is 11, and 14 divided by 1 is 1. So the greatest common factor in this case is actually 1. So when you can't find any other prime factors, right, the greatest common factor, 1 is the answer. Greatest common factor of 1. Okay, let's move on to the next problem. Example, find the greatest common factor. All right, cool. So we are basically going to do exactly what we did previously, but now we have the added variables in here. And this might seem like it makes it much more difficult, but it does not, because the same rules for greatest common factor as far as each element to the lowest power also applies to variables. And I'll show you what I mean by that. So let's do a prime factorization of 21, which is simply 3 times 7. Prime factorization of 18 is going to be 2 times 3 to the second. 45 is going to be 3 to the second times 5. 24 is going to be 2 to the third times 3. And I'll even put the exponents here just to make sure it's explicit. But the greatest common factor, we're going to include each one of these elements to the lowest power. If it's not included in 1, it can't be included in the GCF at all. So let's first focus on the exponent, right? Okay, so we have 2 to the first power, but 2 only is in 2 of them and not in the other 2, so we can't include 2. What about 3? We have a 3, we have a 3, we have a 3, and we have a 3. Awesome. And the lowest exponent is a 1. Okay, so we have a 7, no others. We have a 5, right? So if you go in order, it makes it a little more orderly. So after 3, there's a 4, no 4. How about a 5? We have a 5 there, but there's no other 5. What about 6? No. What about 7? Yes, that's the only one that has a 7. And that's it. So it looks like the GCF so far is a 3. Now what you have to do is you are going to include the variable, the same kind of thing, right? But you don't have to do any prime factorization, it's already there. So we have an m to the 7th, an m to the 6th, an m to the 8th, and an m to the 5th. So they all include an m, and the lowest exponent is the 5. So we are simply going to include m to the 5th, boom, and we're done. Okay, let's try this one. We have an x to the 4th, we have an x to the 7th, we have an x to the 3rd, we don't even have an x. Uh-oh. Well, since that last one does not include the element x, we don't get to include x. All right. Well, what about y? We have y to the 2nd, we have y to the 5th, we have y to the 7th, we have y to the 15th. They all include y, so we get to include y in the GCF. We have a 2, 5, 7, and 15, which means y to the 2nd. The 2 is the smallest exponent, so the GCF here is 2. Now, it still works that the GCF is the largest thing you can divide evenly into all of these. And that should make sense why you have to pick the one with the smallest exponent, because if you have a larger exponent, you're not going to be able to divide it evenly into everything, right? Because this one right here, x to the 4th, y to the 2nd one, because that only has 2 y's in the numerator, I can't divide more than 2 y's into it, right? If I tried to, for instance, divide this by 5, right? If I said y squared divided by y to the 5th, this isn't going to work. I can't divide the 5 into a 2 evenly, so this doesn't work. So that's why you always have to pick the smallest one. Also, another reason is I can't include x because this last one right here, that says y to the 15th, right? But there's no x. So if I was trying to divide, I can divide this by y to the 2nd, that works. But I can't very well divide it by x, right? Because there's no x in the top. So that x has, I can't divide the x evenly, right? So again, it still pretty much means the largest thing you can divide all of them by. But again, if it doesn't have enough of those elements, it won't divide evenly and it won't be considered the greatest common factor. And that's it.